what you have studied in the chapter is sound needs a medium to travel. Sound cannot travel in vacuum, that we have studied. And the sound is a type of wave, and that wave is a longitudinal wave. Now there are two types of wave, that's longitudinal and transverse. Now we are discussing about a wave that is transverse waves, okay, over here. Now I have discussed about few terms which are required in order to measure the amplitude, in order to know about the wave or the nature of the wave. So those terms were wavelength, amplitude, frequency, wave velocity, and all those things. So in this class we will study in detail about all those topics or all those terms, okay, so we understand that better. Now this first graph over here is a displacement time graph. Now graph we have already studied and you are much familiar with the graph, I guess so. So this side, that is the y-axis, is our displacement. That means a wave starting from origin, that is 0 point, it displaces like this, okay, with some time. When the time goes on, this wave will continue. So I've just taken a small section of the wave. So over here, there are few terms which has to be kept in mind. The first one is amplitude. You can look over here, amplitude, this A represents amplitude. It means that from the origin, how much a particle is displaced, or how much a particle has moved upward or downward. So amplitude upward and downward is the same, but only one is positive, one is negative. So the displacement from the origin to its highest point is the amplitude. Or in your book, the definition is given as the maximum displacement of the particle of medium on either side of its mean position. So this is considered to be a mean position. So the maximum displacement of a particle from the mean position, this on the either side is known as the amplitude. Okay, that is amplitude is denoted by the amplitude or the height of the displacement. Second term is time period. Now this T represents time period. So from this diagram, what you can see is the graph or the wave starts from this point. It takes a huge hike over here, it goes down, it comes back to the same mean position. So it completes one cycle. So the time taken to complete one cycle is your time period. Okay, over here also. Now we have measured this from the mean position. In this one, suppose we take this top position and we start our journey from here. We go down, again we come up to the same position. So the time taken to complete one whole cycle is known as time period. Now time period is denoted by T. It is measured in terms of second. Okay, how much time it has taken to complete one cycle, that is your time period. Now another term is frequency. Frequency is the number of vibration in 1 second. Okay, now this vibration which is happening over here in 1 second, how many vibration takes place? That will be your frequency. Frequency is measured in terms of hertz. Simply we write it as Hz like this. Now the relation between time period and frequency. Time period is equals to 1 by frequency, or frequency is equals to 1 by time period. This is very important for numericals and so on. Okay. Time period is measured in second, hertz in frequency. This is right. Now the next term is wavelength. Okay. Now for that, look at this graph over here. Wavelength is the distance between, or the distance from origin till completion of one cycle, like this distance. Distance from this point to this point. This is the length of that wave. There may be a wave of shorter wavelength, like this. Okay, I have just write down. Or for definition, you can tell that wavelength is distance between two crests or two trough. Okay, another choice out there, but distance between two crests is the wavelength. So there might be particles which give shorter wavelength like this one. Okay, this is also a wave, but the wavelength over here, wavelength of this one is way smaller than the wavelength of this one. So this has a smaller wavelength, it has a larger wavelength. So this is wavelength, the distance between two crests, or the distance from the origin to complete one cycle. Okay, till it completes one cycle. That is the wavelength. Now, another term is wave velocity. Okay, now wavelength is denoted by this term. I haven't heard that before, I guess. So this term is termed as lambda. Okay, this you can read as lambda. This is the wavelength. Now wavelength. Length means we talk measured in terms of meter. So we'll use meter to measure the wavelength. For higher wavelengths or for bigger values or for smaller wavelengths, we have another unit, but that you'll study in the higher classes. Okay, for now, just remember meter. Now, the next term is wave velocity. The wave velocity is the distance traveled by a wave in 1 second is called as wave velocity. Means the distance traveled by a wave is called the wave velocity. The wave velocity is denoted by V. Okay, wave velocity is denoted by capital V. It is measured in terms of meter per second. It is velocity after all. So velocity will be measured in terms of meter per second. Remember this part. There will be small m, small m meter per second. Okay, I hope these terms are clear to you now. Amplitude, frequency, time period, wavelength and wave velocity. Okay, the definitions are there in the book. Your work is to note down the definition in your notebook. Okay, and the terms, how it is represented, and even its unit. That you have to remember. Now, we'll find out the relation between. Okay, there's one small derivation which is there in the syllabus. That is what you're going to find out right now. Relation between wave velocity, wavelength, and frequency. Relation between wave velocity, wavelength, and frequency. We are going to find one formula so that we can use it for numericals. Okay. So when you can look here, wave velocity is denoted by V, wavelength is lambda, frequency is small f. So now by definition, what is lambda? What is your wavelength? Okay, I write wavelength. Wavelength is actually distance traveled by wave in one time period. In both the graphs, what you have seen is, you can go back to the portion over here, the graphs were there. You can see that the wavelength and the time period were at the same place. It means that wavelength is distance traveled by a wave in one time period, that is in 1 second. So wavelength is distance traveled by a wave in one time period, that is 1 second. Okay. So distance traveled is, how do you find the distance traveled? Distance is equal to speed into time. Okay, distance is equal to speed into time. Means that over here we are talking about velocity. So in place of speed we are writing velocity of wave or wave velocity. Okay, I write wave velocity so you understand it better. In place of speed we are writing wave velocity into time. Time is time period. So your lambda is equal to wave velocity into time period. So lambda is equal to wave velocity into time period. Now what I have told you, your time period is equal to 1 by f. So we are putting it over here. So time period is 1 by frequency. Or what we are going to do is lambda is equal to v by f. Now Simply we'll take this F this side. So lambda into F is equal to V, or we're just interchanging the position. V is equal to lambda into F. So from here, what you have established is you have found out the relation between wave velocity, wavelength and frequency. So these three terms are related like this. Okay. So in numerical, sometimes in place of frequency we have time period. So for that we use this formula. So this and these three formulas are very important to solve for the numericals, and this derivation is also important. Okay. So now we'll solve few numericals so that will be clear. Okay. Now first one is a heart of a man beat. Excuse me. It is from page number 176, question number 1. Okay, you find a question in the book itself. The question is, heart of a man beats 75 times. A heart of a man beats 75 times a minute. What is its frequency and time period? Question number 1 from page number 176, numerical number 1. A heart of man beats 75 times a minute. So in 1 minute, a heartbeat is 75 times. Okay, heartbeat is 75 times. Now, 1 minute means 60 seconds. It is 75 times. So in 1 second, how much the heartbeat is 75 by 60. So this is equals to 1.25. So now what I have just calculated is the frequency of the heartbeat. Okay, this is the frequency in 1 second, because frequency is number of vibration in 1 second. So this is number of vibration in 1 second. That is your frequency. Okay, that is your frequency. So your frequency is 1.25 Hz. Okay. Now from this, what you have to find next is you have to find the time period. Time period T is equal to 1 by frequency. So it is 1 by 1.25, which is equals to 0.8. Okay, this is for the first part. This was the first question. Now question number 2. It's the same. That is, time period of the simple pendulum is 2 seconds. Find its frequency. Question number 2 is your homework. Remember that, because it's very much similar to question number 1. Time period is given. Simply you have to find the frequency. So for question number 2, you use the formula. Frequency is equal to 1 by time period. This is the formula. Just put the values. You will get the answer. Now for question number 3. Question number 3 is the separation between two consecutive crests in a transverse wave is 100 meters. Now what I have told you is separation between two consecutive crests is your wavelength. So the wavelength is 100 meters. Okay, it's not directly given as wavelength, but it's written as distance between or separation between two consecutive crests, which means the wavelength. Now another information is, if the wave velocity is 20 meters per second, find the frequency. Two things are given, you have to find the frequency. So what we know is wave velocity is lambda into frequency. Okay, so from here, frequency is equals to, if you just want to keep f this side, this lambda will go into the denominator. Right? Lambda. Velocity is 20, and that is 100. So this becomes 1 by 5, which is 0.2. Okay, 0.2. Don't forget the unit, it is Hz. Okay, this is for question number 3. Now, question question number 4. I'll do the last question is question number 4. Or let me check the question. The longitudinal wave travels at a speed of 0.3 meter per second and the frequency of the wave is 20 Hz. So, in this question, what is given is the wave velocity. The longitudinal wave travels at the speed of, speed is given, speed, we can simply write it as wave, we can consider it as wave velocity 0.3 meter per second and the frequency f is given as 20 Hz. So what you have to find is, find the separation between two consecutive compressions. The distance between two consecutive compression. In the previous class I have told you, distance between two consecutive compression or consecutive rest is the wavelength. So it is the lambda which you have to find. So from the same formula over here, what will be a lambda? Lambda will be V by F. So this becomes 0.3 by 20. You can use, I'm sorry, you cannot use a calculator, but if you just calculate this becomes 3 by 200, which is equals to 0.015 meter. Okay, this is what you are getting, wavelength 0.015 meter. Or in your book, it might be written this way. If you remove this point, you get, suppose this is 15, and if you remove the point, how many zeros are can write over here? If you displace a zero from this point to this point, okay, this point to this point, so you are crossing two digits, it will be minus 2. If you are going forward, it will be plus. If you are moving backward, it will be minus. This will be 1.5 to 10 to the power minus 2 meter. Okay, or 1.5. It might also be given as 1.5 centimeter. In your examinations, don't be confused. You can give your answer up to this also. You can do this and do this also, but if all the three answers are correct. If you don't know how to do this, leave it up to yourself. Okay, this is much for today. Question number 5, you can try it out, 5, 6 and 7, or else I'll do solve it in the next class. This much for today. Thank you.